Hello, everyone. It's Mr. Sanchez here, coming at you with part two of the 2013 AP Calc exam, multiple choice exam questions. Today we'll be going from questions 18 through 14, because 18, 19, no, 8 through 14, 8, 9, 10, 11, 12, 13, 14. That's seven more questions. All right, it says a particle moves along a straight line. The graph of the particle's velocity v of t is as time t is shown above. For 0 where JKLM are constants, the graph intersects at t equals 0. So we have this actually crosses here at t equals k, and at t equals m, and has a horizontal tangent line at tj and at tl. For what values is the speed of the particle increasing? So in order for us to know something, a particle speed is increasing when velocity and acceleration have the same sign. So if v of t is positive and increasing, or if v of t is negative and decreasing. That's what we gotta look for. So we're gonna look at the tangent lines, right? So right here, if I look at this tangent line, my velocity. So right here, we're positive, and we're also increasing. So from 0 to j. So from 0 to j, we are positive and increasing. All right, and then so we're gonna divide this up into sections like this. I think the easiest way to show you guys what we're doing is I'm gonna draw some vertical lines right here. All right, so some vertical lines here. Okay. All right, and so from J to K, V of t is positive, but my tangent line is negative, right? So because we're opposite signs, so since my tangent line is opposite, so we are decreasing. Our speed is decreasing when t is between j or k. This is increasing, by the way. So for decreasing, v of t has to be positive and decreasing, and v of t has to be negative and increasing. So that's when our speed is decreasing. That's when our particle is slowing down, or the velocity is slowing down. All right. If you look at here, where our velocity is negative, and our tangent line is negative, so our object is actually speeding up. But we look here, our tangent line is positive, and our v value is negative. So because you have a positive tangent line but a negative velocity, we are going to be decreasing also between L and M. And that will be the answer is C. Okay. All right, next question. Question number 9. Let f be the function given by this, for which value of x is f of not continuous. So in order to find out if this function is continuous at f, we just gotta, it's very simple. Just when is the bottom equal to 0? This is an algebra 1 skill. Algebra 2 skill / pre-calculus. We're gonna have to do this. When does this equal 0? So we cannot equal 0 at these points, because that is where we have holes or asymptotes. So x equals 2 and x equals -1. All right. Don't be fooled. Some people might tell you to cancel this out, but you'd still have a hole at x equals 2. So that's why we gotta include it. Do not do this. Do not do that. All right. You gotta include the whole thing. Question 10. The particle moves along the x-axis velocity v of t. If the particle is at position 2, so at x equals 2, 1 times t, so v of 0 is equal to -2. What is the position of particle at time t equals 3? All right, so position is going to be the integral from, so we know that the integral from 0 root 3 of v of t dt, if we use the fundamental theorem of calculus, we know that that's going to give me x of 3 minus x of 0. My bad, guys. This is x of 0. All right. So we want to get x of 3 by itself. So we know that my position is going to be equal to x of 0 plus the integral from 0 to 3 of v of t dt. All right. That's the formula. That gives us the fundamental theorem of calculus. We know to use this. So this here is called what I call an initial condition. And we usually get that. And then you use, and when what you're looking for, you're going to put at the top integral. And use the fundamental theorem of calculus to find that. So we know x of 0 is negative 2. And we're going to do the integral from 0 to 3 of 3t squared minus 4 dt. So if you take the antiderivative of this, we're going to do some math. That's going to be t to the power of 3 minus 4t from 0 to 3, which this yields t to the power of 3 minus 4 times 3 minus 0 to the power of 3 minus 4 times 0. That goes away. 3 to the power of 3 is 27 minus 12, which is 13. So you're going to have this equals negative 2 plus 13, which is positive 11. No, my bad. It's 15. Mr. Sanchez can't do arithmetic. He is a fraud. All right, negative 2 plus 15, which is 13. And that is our answer for A. All right, keep in mind, I'm going a little bit fast, so that's why I'm probably doing myself. Make sure you double check your work at all times. All right, let f be the function defined from this, and which of the following integrals is the function concave down. All right, so first we're going to have to find f prime of x. So concave down is the thing. Concave down is when the second derivative is less than 0. So f prime of x, you're going to take the derivative of 0 to the x of 2t cubed minus 15t squared plus 36t dt. That uses the second fundamental theorem of calculus, which basically says we get to change the variables. The integral and the derivative cancel each other out, but we're going to end up changing the variables. So we're going to have 2x cubed minus 15x squared. This is a power 2, my bad. X squared plus 36t. So that's what my f prime of x is equal to. And then you take the derivative again, f double prime of x, and you get 6x minus 30x plus, I forgot the x here, plus 36. All right, and then I'm going to factor out the x, the 6. So I'm going to get x squared minus 5x plus 6. And you're going to find out when this is less than or equal to 0. So this is going to factor to x minus 3x minus 2, right? We're trying to see if it's equal to 0. So you're going to do a second derivative test. So you're going to draw a number line. So we're going to test numbers that aren't these. So we have 2, we have 3. This is when f double prime is equal to 0. And then now we're going to test when f of 0. So f double prime of 0. That's going to give you 6 times 0 minus 3 times 0 minus 2, which is 6 times negative 3 times negative 2. Negative times negative is positive, so you're going to have 6 times positive 6, which is 36. So this value is positive. And then I'm going to try a value here, number 4, f double prime of 4. You're going to do 6 times 4 minus 3 times 4 minus 2. 6 times 1 times 2. That's positive 12. So therefore we're positive. Lastly, we have f double prime of 2.5. All right, and you're going to have 6 times 2.5 minus 3 times 2.5 minus 2. All right, so 2.5 minus 3 is negative 0.5, and 2.5 minus 2 is positive 0.5. I don't need to actually do this math. I know that this is going to end up in some negative number. So we're going to be negative between, right, at 2.5, we're going to be a negative double value. And so we're going to say that the f double prime of x is less than 0. So that's when we're concave down. When x is in between the interval from 2 to 3. And that would be 11. Yay, that was doable. And so, that's how we get that question. You gotta know how to do this one involves the second fundamental theorem of calculus, the second FTC, plus the second derivative test. Alright, and now we're going to go to the next question. Question 13. For which of the following does the limit of x prime equal to 0? So this is going to happen. We're going to go ahead and we're going to check what happens when you take the limit as x approaches infinity of ln of infinity over x to the 99. Alright, so ln of infinity, so x to the infinity is bigger than ln of infinity, because if you look at the graphs, x to the infinity, x is going to go exponentially faster, and then an ln function is going to go like this. So no matter what, you're going to have a really big number on top, so you're going to have infinity over a little infinity. A big infinity over a little infinity. So when infinity on top is bigger, you're going to get 0. So we're going to be, this is true. And then when you do the limit as x approaches infinity of e to the x over ln of x, so exponential functions are bigger, so... Oh, my bad, guys. My bad. This is backwards. It's a little infinity over a big infinity. That's how we get 0. And on the top, on this problem, you're going to have a big infinity over a little infinity, because my function goes up really fast, right? So that's going to be infinite. So this one does not count. And then you're going to have the limit as x approaches infinity of x of infinity to the power of 99 over e to the infinity. This was actually infinity to 99. Either way, here, exponentials are the biggest function, so you're going to have big infinity over little infinity, and so you're going to have 0. So it's going to be true for 1 over 3. That's not the best explanations, but there is a hierarchy of equations. I believe it goes exponential functions are the fastest, and then they're bigger than polynomials, and then I believe it's logs, and then it's trig functions. I believe that's the hierarchy of equations. Don't quote me on this. This is just off memory, because trig functions are usually, sine and cosine are defined between two spaces. Logs go very slowly. Polynomials go fast, but exponentials the fastest. Alright, let 3 be the 13. Let f be the differential function. F of 0 equals negative 5. For which of the following is in the bottom positive value of negative f of 2? So this one's an interesting question, because you just gotta try. So if f of 0 is negative 5, right? Let's say f prime of x is equal to 3. So you're going to get, to get the next value, you're going to go negative 5 plus 3. That's going to be 2. Negative 2. All right, so what happens if I have f prime of 2? F prime of x equals to 2, right? So let's say equals to 2. Well, then that means you're going to get negative 5 plus 2, which is negative 3. So those are all possible values. And then let's say I get f prime of x equal to 1. Well, then you're going to get negative 5 plus 0. Negative 5 plus 0. Okay, let me start it over. I seem to have messed up. I'm sorry. So let's say we start at f of negative 3. We'll start at f of 0 equals negative 5. And then you're going to do plus 2 times the slope, right? So let's say f prime of x is, we'll start again with 3. You're going to 2 times 3, because you're going to go 2 values away from it. So the right's over there, run twice. So that's going to be 1. So 1 is a possible value. Let's try negative 5 plus 2. And then we'll say f prime is now 2, right? That's going to give me negative 1. Alright, so negative 1 is a possible value. And then using the intermediate value theorem, if I can get 1 when my slope is 3, when I can get 2 when my slope is -1, when my slope is 2, that means that 0 is possible. And then if my f prime, if I have -5, and let's say my f prime is 0, right, that's f prime of x, then you get -5, and if my slope is negative, I can go down here. So the only possible answer I can get is 2. That's not the best explanation, but just think about it. You have an equation right here. You go 1, 2, 3, 4, 5. 1, 2, 1, 2. All right. So the first situation I showed is what happens if my slope is 3. If my slope is 3, you go 1, 2, 3 over 1, 1, 2, 3 over 1. This one represents, this line represents f prime of x equals to 3. The next one represents what happens if my slope is 2. If my slope is 2, I go up 2 over 1, up 2 over 1, and then I draw a line like this. And then the next scenario, because there exists some slope that's less than 2 and bigger than 3 that will get me here. All right, we can determine that much. All right, and then if my slope is 0, you can just be like, oh, my line's gonna go down here. And because we're being x and 3, you can also have your slope be -5, and then you can also go down here. Right, so those are all the possible ones. But no matter what, if I'm capped on my slope being 3, I'm never gonna pass 2. I'm never gonna reach 2 because my slope would have to be bigger. Number 14, last question. All right, so let f be the function given above. What are the values a and b for which f of x is differentiable? There are 2 things you need to know. In order for something to be differentiable, f prime of x at f prime of 1 has to exist. So let's make sure that the limit as x approaches 1 from the left of f prime of x is equal to the limit as x approaches 1 from the right of f prime of x. So first, what's x prime of the left side? The left side is 1 equal to the right side is going to be 2ax. All right, and that's going to be, now we're going to apply the limit as x approaches 1 rule, the limit as x approaches 1 rule. So you're going to have 1 is equal to 2a times 1. So 1 is equal to 2a. So a is equal to 1/2. So that's the first value we find. Now we got to say that f of x is continuous at x equals 1. So what I'm going to do is I'm going to say the limit as x approaches 1 from the left of x plus b has to be equal to the limit as x approaches 1 from the right of f of a of 1/2 x squared. All right, so now we're going to plug in our 1. So you're going to have 1 plus b is equal to 1/2 times 1 squared, right? Which then gives me 1 plus b is equal to 1/2. And then you do minus 1 to both sides. 1/2 minus 1 is -1/2. And so we have b equals -1/2 and a equals 1/2. That's how we do that problem. All right, guys. That's it for part 2. Have a great day. Hopefully, I'm sorry about messing up in the last question. Bye.